The figure below shows the first 3 diagrams in a sequence. Of course, we are not going to be making use of the first 2. We're just going to be looking at diagram number 3, which is the final diagram that they have given us. We are not going to be looking at all 3 diagrams. We'll be looking at the final diagram that was given to us. The figure below shows the first 3 diagrams in a sequence. Each diagram is made up of dots connected by line segments. In each diagram, there are D dots and L line segments. And we are required to draw the 4th diagram in the sequence. So we are going to draw the 4th diagram in the sequence. By using a representation of the 3rd diagram that we have right there, the 4th diagram may be constructed as follows. So we're going to construct the 4th diagram by making use of the 3rd diagram, or a representation of the 3rd diagram that we have there. In order to draw the 4th diagram, take note of the horizontal spacing of the dots and insert another dot in the middle row with the same spacing as the others. So we have noticed the spacing, and we are going to put another dot with the same spacing right there. The new dot is the center of an X that may be drawn in completing the diagram. There we have it. Complete the diagram by drawing the other 2 horizontal lines. Finally, insert the final dots. There we have it. So that is our 4th diagram in this sequence. We are going to complete that table, and we have there, here, so we have some spaces that are missing, and we are going to complete the table by inserting the missing values. For each element in the middle column, the number in the first column is multiplied by 2 and 4 is subtracted from the result. So that's what we notice, that whatever we have here, we always multiply by 2 and subtract 4 from the result. So we are going to do the same in this column. Do it right there. So we have 62 there, so we have 2 times 62 minus 4. And of course, what do we know? Any number in the 3rd column may be found by simplifying the arithmetic expression of the adjacent column. So whatever we have here is the simplification of this arithmetic process. So we have 2 times 5 minus 4 is equal to 6. Of course, 10 minus 4 is equal to 6. So we'll do the same down here. 2 times 62 minus 4, we have 120. We do not know the number of dots in the row, which is number of dots. We do not know the number of dots right here. So we are going to call the number of dots A. And this is 180. So we know the arithmetic expression that will give 180, that it is 2 times the number of dots minus 4. So it is going to be 2 times A minus 4. So 2A minus 4 is equal to 180. By transposition, we have 2A is equal to 184, and then A is equal to 92. I think we should just put that in the table. The table may be easily completed. So we have here 2 times A minus 4 is equal to 180, and we have determined the value of A. So of course A is 92, and we will say 2 times 92 minus 4, and that is what is required to be inside of that table. How many dots are in the 6th diagram of the sequence? the dots are in a sequence increasing by 3 each time. Notice 5, 8, 11. So we are increasing by 3 each time. So first, second, and third. So we need to go up to the 6th in the sequence. Right. So if we go up in that same manner, the 6th in the sequence will have 20 dots. How many segments are in the 7th diagram of the sequence? So take note of the 7th term in the sequence. Right. So we have the number of dots will be, for the 7th, will be 23. And we know the number of segments will be what? 2 times the number of dots minus 4. So 2 times 23 minus 4. And that is equal to 42. The number of line segments is found by multiplying the number of dots by 2 and subtracting 4 from the result. So that's how we do it. We have no problem here. We have the number of dots 2 times the number of dots minus 4. So the number of line segment is found by multiplying the number of dots by 2 and subtracting 4 from the result. Now let us transpose the expression that we have there, making t the subject of the formula. Our first step in making t the subject of the formula is to eliminate the square root from the right hand side, and that is done by squaring both sides, in which event we realize that the square root side will be eliminated from the right hand side, and we will find the square of each term on the left hand side. So square root is eliminated, we have p squared, and square 2 we get 4. Eliminate the denominator from the right hand side by multiplying by g. So we will multiply both sides by g. Multiplying both sides by g will cause g to be cancelled from the right hand side, and of course we will have p squared g or gp squared on the left hand side. So we have p squared g over 4 is equal to t plus r. So next, eliminate r, that we are adding r here, so we will subtract r from both sides. R will be eliminated from the right hand side, and we will have p squared g over 4 minus r, and that is equal to t. And of course we have t is equal to p squared g over 4 minus r. By a different process, some student might arrive at an answer with a different appearance, and that will be p squared g minus 4r over 4. So either one is right. We have f of x is equal to 2x squared minus 4x minus 3, and we are required to write it in a form which is, of course, by the process of completing the square. So in completing the square, what do we do first? We eliminate the 2 here, but we cannot just cause it to evaporate into thin air. We have to maintain the expression being equal in all respects as we go through the process. So we'll take 2 as a factor of the first 2 terms. In so doing, we have 2 as the factor. 2 into 2x squared is x squared, and 2 into negative 4 is negative 2. 13 is outside of the bracket and is not affected. to complete the square on what we have on the inside of the brackets, we will take half of the middle coefficient and square it. So half of the middle coefficient and square it. So we have half of negative 2 is negative 1. When we square negative 1, we get a positive 1. That positive 1 will be included inside of the bracket right there. So we have x squared minus 2x plus 1. However, we have introduced a positive 1 that was not there before. So we need to subtract 1 from the entire expression. However, this 1 that we have here is first multiplied by the 2 that we have there. So everything inside of this bracket is being multiplied by 2. So we say 2 ones 2, so we need to subtract 2 at the end. So at the end we have negative 13 minus 2, that is negative 15. And we say what? What do we square to give 1? We square 1 or a negative 1. We'll choose a negative 1 because that is the only way that we can get a negative middle term. The middle term is negative only if this 1 is negative. So we square a negative 1 to give 1, and we square x to give x squared. But do not forget that in a perfect square, there is a middle term that we have right here, which is equal to 2 times the first times the second. So the completed square is 2 times all of x minus 1 all squared, and from that we subtract 15. Next we need to determine the values of x at which the graph cuts the x-axis, and we know that where the graph cuts the x-axis, f of x is equal to 0. So we have the completed square from the previous slide, and we are going to use that completed square in order to solve the equation 2 times all of x minus 1 all squared minus 15 is equal to 0, because as a matter of fact this is what f of x is equal to if we completed the square. So we are going to use the completed square, which is of course the same expression that we had before. We are going to equate that to 0, and by solving that equation we will arrive at the 2 x-intercepts, the values of x at which the graph cuts the x-axis. So transpose negative 15, add in 15 to both sides, 15 will be eliminated on this side, and we have 15 on the right hand side. Next step, we need to divide through by 2. 2 is going to be eliminated from this side. We have 15 over 2 on the other side. And 15 divided by 2 is 7.5. Then we need to eliminate the square by finding the square root of both sides. By so doing, the square is going to be eliminated from this side, and we need to find the square root of the other side. Finally, of course, we have to eliminate the 1 from this side, so we will have this negative 1 to be a positive 1 on the other side, and of course the square root of 7.5 is positive or negative 2.74. Do not forget that when the square root exists, it exists in pairs, 1 positive and 1 negative. So the values of x will be 1 plus 2.74, which will give us 3.74, and 1 minus 2.74, which will give us a negative 1.74. Now we need to also determine the values of x for which f of x is less than or equal to 0. So we are sure that this is our situation where we are looking for f of x is less than or equal to 0. That is where the curve is below the x-axis. So this point and below, this point and below, because we do not have less than, we have less than or equal to. So we are talking about this point and below, this point and below. So we are talking about the region in which the curve is at the axis and below, and we need the values of x for that region. So what do? We will see that the values of x for which the curve is below the x-axis are between negative 1.74 and 3.74. So as we are going below the axis where the curve is, or f of x is less than 0, notice that the points are going like that. So as we go down, we are showing that the points are in this region. Notice as we go below the axis, the points are going together. So we are talking about that particular region. So in that region, we can specify that the region is between negative 1.74 and 3.74 inclusive. So we may write that as the set of x such that negative 1.74 is less than or equal to x is less than or equal to 3.74. We need to determine the minimum value of f of x. So the minimum value of f of x is the constant value after we have completed the square. So of course we have the completed square as the left hand side of that equation that we have there. The completed square is the left hand side. So the minimum value is the constant value that we have there after we have completed the square. So the minimum is negative 15. The value of x at which it occurs, or the minimum occurs, when the expression inside of the bracket is equal to 0. So the expression inside of the bracket is x minus 1. So x minus 1 is equal to 0. The value of x is equal to 1. We have two functions, f of x and g of x. First, we will find f of 6. In order to find f of 6, we will substitute 6 in the place of x in the function f. So in this function f, where we see x, we put 6. So f of 6 is equal to 6 minus 3. So we have f of 6 is equal to 6 minus 3, which is equal to 3. We need to find f inverse of x. F is only comprised of one arithmetic operation. There is only one operation in f of x. To find f inverse, just reverse the single operation. So it's x minus 3. That is what f of x is. So f inverse of x is equal to x plus 3. We need to show that f of g of 2 is equal to f of g of negative 2, and that is equal to 0. So show that f of g of 2 is equal to f of g of negative 2, and that is equal to 0. So let's go straight ahead. To find f of g of 2, we find g of 2 first. So g of 2 is equal to 2 squared minus 1. So g of 2 is equal to 2 squared minus 1, which is equal to 4 minus 1, which is equal to 3. Now we need to find f of g of 2. So g of 2 is equal to 3, so we need to find f of 3. So f of 3 is equal to 3 minus 3, which is equal to 0. So do the same with f of g of negative 2. So f of g of negative 2 is what we need to find. So find g of negative 2. G of negative 2 is g of negative 2 equals negative 2 squared minus 1. So negative 2 squared minus 1. when we square negative 2, we get positive 4. So 4 minus 1 is equal to 3. Then we need to find f of 3. F of 3 is exactly this. F of 3 is 3 minus 3, which is equal to 0, which is, of course, the exact same thing as we have right there. So we are sure, and we have proven, that f of g of 2 is equal to f of g of negative 2, and that is equal to 0. We see that the result obtained in both cases are equal. The distance-time graph describes the journey of a train between two train stations, A and B. Answer the questions on the answer sheet. So we're going to answer the questions that are going to be asked. For how many minutes was the train at rest? At rest, distance does not increase nor decrease. So it does not increase, it does not decrease. Distance remains the same. That is what we mean when we say that the train is at rest. Distance remains the same. And that is the region that the train is at rest. Between 40 and 60 minutes. So we have 60 minus 40 is equal to 20 minutes. So we need now to determine the average speed of the train in kilometers per hour on its journey from A to B. Average speed. Speed is equal to distance divided by time. The minutes may be converted to hours by dividing by 60. So V is equal to 100, and that is what? 100 is the distance traveled. So 100 kilometers. So distance divided by time. But do not forget that although we are dividing by time, the time from A to B, which is the time it takes to get right here, right? So the distance divided by the time is what? From 0 to 40. So we are sure that it is what? 40 minutes. So we are dividing by 40 minutes. But do not forget that although we are dividing by 40 minutes, we need our time in hours. So 40 minutes divided by 60, and that will give hours. So we are going to divide 100 by this fraction, which is the time in hours. Of course, in dividing by a fraction, we multiply by its reciprocal. So we have 100 multiplied by 60 over 40, and of course, we can reduce this fraction and simplify, and we will get V is equal to 150 kilometers per hour. And what students should always try to do is know the difference in calculations that must be made between a distance time graph and a velocity time graph. And we have to be careful to use the principles. If students do not remember, they can consult Richard James Mathematics Resources. Functions Part 2, and of course Functions Part 2 is Volume 3 in Richard James Mathematics Resources. Now, the train continued its journey away from station A and B to another station C, which is 50 kilometers from B. The average speed on this journey was 60 kilometers per hour. So it travels from B to C, and the average speed is 60 kilometers per hour. We need to calculate, and of course it is 50 kilometers away from B. So we need to calculate the time in minutes taken for the train to travel from B to C. So we know the speed and we know the distance. We need to calculate the time. And the time, it said that we need to determine the time in minutes. But of course we have the speed in kilometers per hour and we have the distance in kilometers. So what do? Time is equal to distance divided by speed. Right. Time is equal to distance divided by speed. This will give hours. So the time will be in hours. To convert to minutes, we will multiply by 60. So when we divide, we will get our time in. If we divide distance by speed, we will get our time in hours. But we need the time in minutes. How do we convert hours to minutes? By multiplying by 60. So we will not do that in a different step or in another step. We will do that in the same step. Divide and then we multiply by 60. We say distance divided by speed multiplied by 60 and we get 50 minutes. So we are sure that the time will be 50 minutes. Next, we will put that part of the journey on the graph. So we need to go another 50 minutes. Right there. Another 50 minutes. And then, of course, the distance will be another 50 kilometers. There. So, complete the journey, and that is how we do it. A line that goes from here all the way there. We have a table right here that needs to be completed. We are going to complete it on the principle that y is equal to a half of tan x. So y is equal to a half of tan x. So substitute 20 because 20 is missing. The corresponding value of y when x is equal to 20 degrees is missing. So substitute 20 in the place of x. So we have a half of tan 20. And what is a half of tan 20? A half of tan 20 is a half of 0.36, which is 0.18. And then we do the same for 40. A half of tan 40, half of 0.84, and that is equal to 0.42, and 0.42 also takes its place in the table. We need to plot the points now. I need to point this out, that on the actual examination paper, we did not have 0.13 for the value of x is equal to 10 degrees. But if we do the calculation for ourselves, we will realize that a half of tan 10 is actually 0.13. So let us plot that one. 10 degrees, 0.13. Another 20 degrees, 0.18. 30 degrees, 0.29. And of course we put our little point right there, marking it with an X at every single step of the way. 40, 0.42, 50, 0.60, 60, 0.87. So we are going to just draw a smooth curve through all those points. Draw a horizontal line at y. And why are we doing that? We need to determine from the graph the value of x where y is equal to 0.7. So y is equal to 0.7 and we need to determine the value of x. So we find 0.7 on the y-axis and we draw a broken line to meet the curve, like so. Then we draw a vertical line to meet the other axis. So at that point of intersection of the curve and the horizontal line, we draw a vertical line to meet the x-axis, right? And at that point, x is equal to 54 degrees. And one that we always expect, one of our favorite, circle theorem. The first angle that we need to determine is OAE. OAE, right? And of course, AE is a tangent, and this is a radius. Right, so the tangent and the radius meet at right angles. So OAE is 90 degrees. What about the other one? AOB. 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 Well, there are many ways that we can look at it, but let's see what this particular solution is making use of. For two of the angles in the quadrilateral OAEB, radii and tangents meet at right angles. So BAE is equal to 90 degrees. The only unknown angle is AOB. So we have what? AOB is equal to quadrilateral. All its angles in a quadrilateral will be 360 degrees altogether. And we are going to subtract this one, which is 90 degrees. This one is 90 degrees. And of course, this one is 48. So AOB is equal to 132 degrees. Now, don't forget, tangent meeting radius 90 degrees. Tangent meeting radius 90 degrees. So we have two angles of 90 degrees, and this one is 48. So we are going to subtract from 360. Also, in this particular setup, we could have make use of the fact that we know that these two angles will be equal to 180. So these two must add to give 180 if the total must be 360. So we could have just subtract 48 from 180 and the result would have been 132 degrees. Also, next we need to find ACB. Where is it? ACB. There we have it. ACB. And our premise is, if two angles are subtended by the same arc, the one at the center is twice the one at the circumference. So this one at the center is twice the one at the circumference. Therefore, 132 is twice this one. This is the arc that the angles subtend. This one is at the center. 132 is twice the one at the circumference. Notice the arc. Notice that this angle spans the arc, and also this one spans the arc. So the one at the center is twice the one at the circumference. So this is twice this. So whatever this one is, to find the value of this, we divide by. ACB is equal to 132 divided by 2, which is equal to 66 degrees. quadrilateral ACBD is cyclic with all vertices touching the circumference of the circle. That is why it is cyclic. Opposite angles of a cyclic quad are supplementary. Therefore, in this cyclic quadrilateral, we need to find ADB. ADB is opposite to 66 degrees. Therefore, they will both add to give 180 degrees. They are supplementary. Opposite angles of a cyclic quad are supplementary. So, ADB is 180 minus 66, which is equal to 114 degrees. In this particular setup, we need to determine the length UW. Now, UW is opposite to this known angle, and the two sides that form the angle are known. In this particular case, we will use the cosine rule. In any triangle that we have two known sides and the angle that the two sides form, the cosine rule may be used to find the length of the side that is opposite to the angle. And of course, we have UW squared is 8 squared plus 10 squared minus 2 times 8 times 10 cosine of the angle that the two sides form, which is 60 degrees. So, simplification, we square 8, the result is 64, and we square 10. Of course, cos 60 is 0.5, which is something easy to manipulate. So we have 2 times 8 times 10 is 160 times 0.5, and that no doubt will be 80. So we have 64 plus 100, which is 164 minus 80, and that is equal to 84. So UW is equal to the square root of 84, and that gives 9.17 meters. When a side and an angle opposite to each other are known, the sine rule may be used to find any side or angle when the one opposite to it is known. So if we have a particular triangle with one known side and the angle opposite to it, so the side is known and the angle opposite to it is also known, we may find any side or any angle as long as the angle or side opposite to that one is known. So in this case, we need to find the size of the angle UVW. So the angle is UVW. That is the angle that we need to know. Now in this triangle, we have this angle is known and the side opposite to it is known. We may find UVW, which is this angle, because the side opposite to it is known. So we are going to apply the sine rule in this case. So we are going to call this angle V. So sine of V over 9.17 is equal to sine of 40 over 11. And of course we will transpose, and after transposition we will simplify this expression, and we get sine V is equal to 0.536, which we know to be a little bit over 30 degrees, probably in the 30s or lower 40s. So we have V is equal to sine inverse of 0.536, which is equal to 32.4 degrees. We need to find the area of the triangle TUW. The area of any triangle may be found by taking half of the product of any two sides and multiplying the result by the sine of the angle that the two sides form. So area is equal to a half of 8 times 10, which is, we have the two sides 8 and 10 forms the angle 60. So it is half times 8 times 10 sine 60. and that simplifies to give area is equal to 34.6 meters squared. The diagram represents the surface of the Earth. Of course, the north and south poles are labeled with N and S. The equator and the Greenwich meridian are also labeled. We have other features of the diagram that are not labeled. So let us go straight ahead and label them. The first one, we need to have the 30 degrees north and 20 degrees south. Those are, of course, circles of latitude. So let us label them 30 degrees north and 20 degrees south. Others that are not labeled, 40 degrees east. That one is not labeled. 40 degrees east, we have labeled it now. We have a point with coordinates 30 degrees north and 40 degrees east. That's the one. And do we have another one? 20 degrees south and 40 degrees east. Okay. So 20 degrees south and 40 degrees east, so the intersection of those two lines. We will now find the shortest distance between P and Q. And of course, the distance from P to Q is represented by this arc that we have right here. So we need to determine the length of that arc. And the length of an arc, as we know, is the particular fraction of a circle. The circle that we have here is a circle of longitude that has the same radius as the radius of the Earth. And we need to determine the angular representation of that arc in order that we can find the associated fraction. P is 30 degrees north and Q is 20 degrees south. The angle is 50 degrees. So we are going to find the length of the arc PQ, and we are going to use Module 2 of Richard James Mathematical Resources on Earth Geometry. We are going to use that. And of course, Module 2 is the formula used to determine the length of an arc. So there we have it. We have P and we have Q. P is 30 degrees north and Q is 20 degrees south. So we have a total of 50 degrees. So we have PQ is 50 over 360 times 2 times pi times r. So we have 2 pi r is the circumference of the circle, and the particular fraction is going to be the fraction associated with the arc divided by the angle of an entire revolution. And that simplifies to give 5,561 kilometers. We need to determine the radius of the circle of latitude on which Q is located. The radius of any circle of latitude may be found by using Module 1. And of course, the radius of any circle of latitude is equal to the radius of the Earth multiplied by cosine of the angle of latitude. So we have radius is equal to 6,370 times cosine of 20, and that gives 5,986 kilometers. So given the following diagram, we are required to write the vector OP and OQ in the form of column vectors. So let's go straight ahead. OP is 3 units in the positive x direction, 2 units in the positive y direction. So we have OP is equal to 3, 2. OQ is negative 1 unit in the x direction and positive 3 units in the y direction. So OQ is equal to negative 1, 3. R as coordinates 9, 8. So we are going to express QR as a vector in the form of a column vector. So by the triangular law, we have QR is equal to OR minus OQ. And do not forget that R has coordinates 9, 8. So we have 9, 8 minus negative 1, 3, which is of course OQ. So we have 8 plus 1, negative, negative. So 8 plus 1 and 9 minus 3. So we have QR is equal to 9, 6. Now we need to show that OP is parallel to QR. Well, if they are parallel, so we need to show that OP is parallel to QR. So we have QR. This is QR. QR may be written if we take a factor of 3. So 3 into 9 is 3 and 3 into 6 is 2. So QR is 3 times 3, 2, which is of course 3 times OP. So QR is equal to 3 times OP. And of course, if one vector can be written as the product of the other and a real number, then those vectors are parallel. OP is parallel to QR because OP is 3 times QR. Now we are required to determine the magnitude of the vector PR. But before determining the magnitude of the vector PR, we need to use a triangular law to find the vector PR. So PR is equal to OR minus OP. So OR, we have OR as 8, 9, and of course we know OP to be 3, 2. So 9 minus 3, 8 minus 3 is 5, and 9 minus 2 is 7. So PR is equal to, of course, the square root of, that is the magnitude of PR, is equal to the square root of 5 squared plus 7 squared. 5 squared is 25, 7 squared is 49. So we have PR is equal to the square root of 74, which is 8.6 units. The point S has coordinates AB. Write QS as a column vector in terms of A and B. And of course we will be applying again the triangular law. So QS is equal to OS minus OQ, and S has coordinates AB, so we're going to write OS, that vector, in a column form, column vector form. So we have OS is AB, and we are going to minus OQ that we know already from the previous slide to be negative 1, 3. So we have AB minus negative 1, 3. So we have A minus minus 1, so that's plus 1, and B minus 3. So that is what QS is equal to. and we are told that QS is equal to OP. So if QS is equal to OP, what do we do? In finding A and B, we say this is QS, and of course we know OP from the previous slide. So we have A plus 1 is equal to 3, and we solve that equation. So A plus 1 is equal to 3, so A is equal to 2, and of course B minus 3 is equal to 2, so B is equal to 5. Using a vector method, show that OPSQ is a parallelogram. To show that OPSQ is a parallelogram, we are going to make use of the fact that opposite sides of a parallelogram are equal in length, and of course they are also parallel. We already know that QS is equal to OP. We already know that QS is equal to OP. So we have it right there. QS is equal to OP. So we have 3, 2, 3, 2 there. They are equal. We now need to show that OQ is equal to PS. So OQ is equal to PS. So OQ is equal to -1, 3. We know that already, that OQ is -1, 3. So we need to use the triangular law to find PS. So PS is OS minus OP. So by making our calculation, we have OS minus OP. 2 minus 3 is -1, and 5 minus 2 is 3. So we have opposite sides are equal, and that is what we have for these opposing sides also. Now when we are using a vector method to show that a particular figure is a parallelogram, we may use also the argument that in a parallelogram we have these two sides are equal and parallel. If we are using a vector method, it is not necessary for us to show that these two sides are also equal and parallel. If we are using a vector method, showing that two opposite sides are represented by the same vector is enough to show that a quadrilateral is a parallelogram. So we have the opposite sides being represented by the same vector, so we are sure that the figure is a parallelogram. The first requirement of this problem is that we find a particular matrix product, that is 3AB. But the matrices A and B are not given right here. These matrices belong to another part of the same problem. So we have A is 1, 2, 2, 1, B is 1, 3, 2, 5. So multiplying a force, we are going to find the matrix product first. So we're going to multiply the two matrices first. So we have the upper times the left. The answer goes to the upper left. 1, 1 plus 2, 2. Then we have the upper times the right. The answer goes to the upper right. So we have 1, 3 plus 2, 5. Then we have a lower multiplied by the left. The answer goes to the lower left. 2 times 1 plus 1 times 2. Then the lower multiplied by the right, the answer goes to the lower right, that is 2 times 3 plus 1 times 5. Simplifying the result, we get 5, 13, 4, 11. We multiply that by 3 and the result is 15, 39, 12, 33. Next, we will state the effect of the matrix V on the triangle ABC. That is not given here, but the matrix V will have the same effect on any figure that it is transforming. Any diagonal matrix with the two non-zero elements equal represents a size transformation. The matrix is a size transformation, as a matter of fact, an enlargement with scale factor 2 that is centered at the origin. So we have the diagonal matrix, the two numbers in the leading diagonal are equal, so this matrix always represents a size transformation, and the scale factor will be the equal numbers that we have right there. So the scale factor is 2. We need to determine the 2 by 2 matrix that will represent the transformation V followed by W. So V followed by W. In order to determine that matrix, we need to multiply the matrix to form the products WV. So we put W first, then V, and we find the product. Of course, finding the product is not very difficult, because we know that in this case we have 1 times 2, negative 1 multiplied by 2, and this will turn out to be 0, so we know that we only have negative 2. In this we have negative 1 with 0 and 0 with 2, so this will turn out to be 0. Then this 0 with 2, which is 0, and then 1 with 0, that is also 0. So the multiplication of these matrices is not very difficult at all. So we have finally 0 multiplied by 0 is 0, and 1 multiplied by 2 is 2. So need to determine the image of the coordinates of the triangle that we have right there, the triangle ABC, and we are going to use the matrix that we have just found to determine the image. So find the images by converting the coordinates to column matrix, by which we will multiply the matrix of transformation. So we have A right there, write it as a column of the matrix, and then B will be the other, and C the final column of the matrix. So after we have put those together, what do we know? We'll be required to multiply by this matrix. And of course, multiplying by that matrix, let's see what happens. When we are doing transformations, we will not exhaust the upper row and then move to the upper row. We'll find the image by finding the image of A first and then finding the others. So we'll go to find the x-ordinate of A. So we say negative 2 times 1 plus 0 times 2, and that will be a negative 2. Then we say 0 times 1 and 2 times 2 is 4. So we have a negative 2, 4. Of course, we may use the pattern to complete the other calculations without actually going through the matrix multiplication, because there is no doubt that both ordinates are multiplied by 2. As we can see, both ordinates are multiplied by 2, and the sign of the one at the top is changed. So we do the same, multiply both ordinates by 2 and change the one at the top. So 2 times 1 is 2 and 2 times 1 is 2, and then change the sign at the top and then do the same here. Because usually when we are using matrices of transformation, especially for the basic ones that we do in CSEC, we can follow a pattern. If we cannot follow a pattern, then we have to multiply in order to determine the value of every single ordinate. But in this particular case, we may make use of the pattern that we have. And of course, that is dependent on the accurate calculation of the first one. So if we do the first one accurately, then we may just write down the answers of the others. But in this particular case, as in many questions in CSEC, the coordinates are required. So the problem required coordinates. So we are going to write the points in coordinate form. So those are the points in coordinate form. We have a pair of simultaneous equations. 11x plus 6y is equal to 6 and 9x plus 5y is equal to 6 that you may find on your question paper, and we are going to first write that system in matrix form. So write the coefficients of x and y in a 2 by 2 matrix. So that's what we are going to do. The coordinates of x and y are 11, 6, 9, 5. That we are going to write in matrix form. Then we will multiply by xy as we have it there in a column matrix, and that is also equal to the answers that we have for the two equations, and those are 6 and 7. Hence, write the solution of x and y as a product of two matrices. So we are going to write that as a product of two matrices. So what do? xy, we are going to take the inverse of this matrix and multiply that on this side. And let us look at the reason for doing that. If we are going to find xy, we are going to, if we just use normal arithmetic, divide by 11, 6, 9, 5 on this side, and we will divide by 11, 6, 9, 5 on the other side. But we cannot divide matrices, so we multiply by the inverse. So we will multiply by the inverse of this on the left hand side and of the same thing on the right hand side. The left hand side will turn out to be xy because of the cancelling effect of this matrix and its inverse. The right hand side will have the inverse of this matrix. So the inverse of this matrix, to find the inverse of this matrix, we put 1 over the determinant. 11 times 5 minus 6 times 9. So we have 55 minus 54, and that is equal to 1. So we will have 1 over 1 right there, which is equal to 1. And of course we know that 1 multiplied by anything is that same thing. Here we have the adjoint of this matrix, which is change the places of these two. That is what we have done here, and change the signs of these two, and that we have right there. So on the left hand side, this turns out to be 1 over 1, which is equal to 1, and 1 multiplied by anything is that same thing. So we can forget about this fraction as we write the answer. So we have xy is equal to this multiplied by 6, 7, and that's all there is to it.